This is section 3.5, number 25. Question says, estimate the square root of 65. So what we're going to do is use linear approximation. And so the first thing I'm going to do is look at the function itself, which is the square root function. So I'm going to say plot function here, and I'm going to say plot the square root of x. And now we want to estimate the square root of 65, and we know that it looks like this. But if we look here, I'm going to just move this over, okay? We know the square root of 65 is over here somewhere, right? So the first thing I need to do is I'm going to right-click on properties here so I can extend the plot to go to, I don't know, let's go to 79. There we go. So now this is the function that we're looking at, and we want to say, what is the value right about here at 65? Well, we don't know what that value is, but we do know the square root of 64. So we're going to use 64 and do a linear approximation using the tangent line at 64. Okay, so once again, we want to write the linear approximation for the square root of 65 using y minus y0, or y naught, right, is equal to the slope times, is equal to the slope times x minus x naught. All right, and so in this case, we're first going to use x naught and y naught to be, I'll put it like this, okay, so x naught, y naught. X naught is 64, and the square root of 64 is 8, which we know. Now we just need to figure out what m is and put those values back in. So m is the slope of the tangent line when x is 64, okay? So the slope of the tangent line is also equal to the derivative. So this is x to the 1/2, right? So then dy dx is going to be equal to 1/2 times x to the negative 1/2 power. Okay, so when you now we want the value dy dx evaluated when x is 64. So we get m, the slope, right, or dy dx is equal to 1. Let me just do it this way, actually. Let's just calculate it, right? So we're going to say number, calculate. It's 1/2 times x, which is 64, to the negative 1/2 power. So times 64 to the negative 1/2 power. Okay, so that is 0.0625. So this is the slope, and now we're gonna use this equation here. Okay, so my new equation, I'll put it under here, is y minus 8 is equal to this slope times x minus 64. All right, so then we're going to get y is equal to this times x, well, let's just do it this way. Okay, x minus 64 plus 8. So now, let's, this is the slope of the tangent line at x is equal to 64. So how do I know that's true? Well, I'm going to plot that function, okay? So I'm plotting this function, which is going to be that times the quantity x minus 64 plus 8. Boom! Kind of hard to tell here, but you can see that that is a line that, I'm going to make this graph be rectangular, okay? And that, now you can see that right at 64, this is the tangent line. But you can also see that the linear approximation pretty much falls along the line anywhere in the 60 range. So what we can say is that this is going to be a good approximation. This is going to be a good approximation for any value of x. So what we're going to just do now is put in the 65 right there. So I say number calculate g of 65, and we get 8 point, I can just make the value 100,000, and we get 8.06250. So what you're saying is that, which makes sense, right? If the square root of 64 is 8, the square root of 65 is 8.06250. And we can actually calculate this using just saying the square root of 65. And what you can see is 0.06226, which is very, very close to this one. Again, it's off by the 10,000ths. So it's a very good estimate. So I hope that this has been helpful.